Hello, precalc, and welcome to section 2 of chapter 4. Again, we're continuing with the unit circle. So last time we talked about where the angles were and how to do it in degree and radian. This time we're going to start to add a little bit of value to those angles. So what points actually are there on the unit circle? So make sure you have your notes out and let's go. Okay, we're going to use the unit circle to define trig functions. We're going to recognize domain and range. Exact value of functions, we're only working on pi over 4 right now. We'll continue that in the next section where there are a little bit more. We're going to talk about even and odd, identities, periodic functions, that just means it repeats, and evaluate a trig function with a calculator. So make sure you have your calculator out and you know how to get between degree and radian again. All right, a unit circle, the only thing special about this is it has a radius of 1. That's why it's called a unit circle. There is 1 unit. So R is always 1. And it's centered at the origin, right here. And now we're going to find what all these values are around my unit circle. So what points actually lie on it, right? The equation is x squared plus y squared equals 1. So what they're doing is they're going here and they're drawing a line straight down, creating this 90-degree triangle. All right, from geometry, you know, well, hopefully it stays on there, that x squared plus a squared plus b squared equals c squared, correct? Well, this time your a is x, your b is y, and then your r is always 1 because it's the unit circle, it's your radius. So x squared plus y squared equals 1 is really a squared plus b squared equals c squared. Nothing fancy here. All right, so the radian measure of a central angle equals the length of intercepted arc. So remember this right here, this radian measure is the same as S out here is what that's telling you. All right, so now if we want to find sine, we know that sine is opposite over hypotenuse. So if we know that sine is opposite over hypotenuse, which you learned in geometry in algebra 2 and algebra 1, then you know you're up here at your angle here. Well, opposite is y, hypotenuse is 1, so sine is y. Cool. Yeah, let's draw this a little bigger so you can see. Oops. All right, so this is my unit circle, right? This is 1. We know that opposite is y and adjacent is x. And that's all you're using for your sine and cosine. So opposite here is y over 1, which is your sine. Cosine then is x over 1. So cosine is adjacent over hypotenuse, x over 1. Tangent, y over x. All they're using is what you already know. Then remember, cosecant, secant, and cotangent are your reciprocals of your sine, cosine, and tangent. Old geometry. Kind of fun, right? Okay, here we go. This is my point, all right? So if I give you square root of 3 over 2 and 1/2, that means that this is the x value, which is down here, the square root of 3 over 2, and this is the y value, which is here. And we know that the radius is 1. So now if I want to know the sine of t, it is 1/2 because it's y over your radius, which is 1. So it's 1/2 over 1. The cosine of t is the square root of 3 over 2 over 1. So the cosine is your x value. The sine is your y value. You know your tangent is when you divide these two. Well, they have the same denominator, so that just cancels. And you get 1 over the square root of 3. When you see this written, they will always rationalize the denominator. So they will write the square root of 3 over 3, which is the same thing. Okay, cosecant, secant, cotangent. Now do your reciprocals. 1/2 is 2. Square root of 3 over 2 is 2 over square root of 3. And 1 over the square root of 3 is just square root of 3. All right, so you remember in all your geometry, right? Okay, we'll do one of these together, then I want you to pause and do the rest. In this first area here, right? I know that x is positive and y is positive. Here, I know x is negative, y is positive. Here, you know x and y are negative. Whoops, that's just a straight negative sign. And here, x is positive, y is negative. No matter what point you pick, correct? Now, that tells you what the sine, cosine, tangent are in those function. So we know sine is based off of y, right? So I look at y. Y is positive in first quadrant. This is second, 90 to 180 goes here, right? So I look at y again, y is positive. Okay, now 180 to 270, that's my third quadrant. And I know y is negative. And then 270 to 360, that's the fourth quadrant, and it's negative. So quadrant 1, quadrant 2, quadrant 3, just a different way to write them, quadrant 4. All right, pause and fill in your signs. Okay, I hope you did a good job. Cosine, we realize is the x value. So you look at the x value. So you know x is positive in the first and the fourth quadrant, negative in the second and third. Tangent, you're dividing these two here and here. Positive divided by positive is positive. Positive divided by negative is negative. Negative divided by negative is positive. Negative divided by positive is negative. Cosecant should be the exact same as the sine. Secant is the same as the cosine, and cotangent is the same as the tan. Those are just reciprocals, so the sign does not change. Now I want you to actually try some stuff here. Here's your point. I would like you to find all 6 trig functions. Pause and go. Draw your triangle larger if you need to. All right, I hope you did a good job. You can do this with or without the triangle. Remember, sine is y, so that's negative 4/5. Cosine is x, so that's negative 3/5. Tangent, you're dividing these two. Since they have the same base, it's just the negative 4 over negative 3, which gives you a positive 4/3. For your cosecant, secant, and cotangent, you just invert them. Don't forget to put the theta here. It's very important. You cannot have the sine of nothing. The sine, cosine, and tangent are functions. So it's got to be the sine of the angle. So the theta is very important. All right, I hope you did a good job. When you look at this, the domain of the sine and function and the cosine is negative infinity to infinity. And that comes from what can the angle be? Well, remember in our last thing, we could add or subtract 360 as many times as we wanted. That means my angle can be any measure. I can go from a small angle to a huge angle. It will still be in that unit circle because all you're doing is going around and around and around. All right, as many times as I want. So I can go from negative infinity to infinity. But if you look at the range value or the y, my unit circle is only 1 to negative 1. It's as big as it will get. It will just keep oscillating in here. So my range is negative 1 to 1, and my domain is negative infinity to infinity. I hope that makes perfect sense to you. It will sooner or later. So basically, when we go to draw these out, if we unravel it, like a sine wave starts at 0, right? It will go up to 1, right? And then it's going to go back down to 0, and then it's going to go down to negative 1, right? Because it's going to continue to do this as many circles as I go. It will go back and forth and just keep going back and forth. That's why it's called a wave. But the highest it will ever get is 1. The lowest it will ever get is negative 1. And it will always go, it will start here and go up and down. And I can go along as far as I want. So it can go to positive infinity or to negative infinity. Maybe the picture helped. Here we go. Exact values of the trig function at pi over 4. So we are only working with pi over 4 or 45 degrees. They mean the same thing, right? So I want to know what these points are or what the sine, cosine, tangent values are for my unit circle. So the first thing we know is that I want to do pi over 4. This is a 45 degrees. We picked this one. Okay, sorry about that. All right, so our back values is what we're talking about at pi over 4 or 45 degrees. All right, so when we go this, we're just going to do the 45s because we like this triangle. So when you draw your triangle from geometry, remember 45, 45, and 90. So your sides were the exact same. Then we used a squared plus b squared equals c squared, right? So then to find this here, we did 1 plus 1 equals 2, which is c squared. So that meant c equaled the square root of 2. But now in our unit circle, this has to be 1. So we divide everybody by the square root of 2. Good to this point? So if we do that, and we know that we have now your x and y on your point here. So our triangle on our unit circle now, oh, it's right down here, is the square root of 2 over 2, square root of 2 over 2, because we rationalized our denominator, correct? Multiplied by the square root of 2. So we got the square root of 2 over 2. So now that we've done that, we know this point value. So now we can find all of our trig function on the unit circle. So remember, this is x and this is y. So x is the square root of 2 and y is also the square root of 2 over 2. So now we know sine is, or the sine of theta is the square root of 2 over 2. Cosine is also the square root of 2 over 2. And then your tangent's going to be 1 because you take this one divided by this one and then our reciprocals. That's our 6 trig function. So here I want you to pause and write them in. All right, I hope you got those right. Now as you go around your circle, they're just going to change where they are. So now if I go up to here, because that would be another 45, the only thing that's going to change is the sign. So now I know x is negative here, so it's going to be negative square root of 2 over 2, and the y is going to stay the same, square root of 2 over 2. On this one, they're both going to become negative, negative square root of 2 over 2, and the negative square root of 2 over 2. And then when you go this direction, down for your 45, now I know x is positive, square root of 2 over 2, but y is now negative. So once you know 145, you know all of them. The only difference is where they actually fall. Now let's look at these 90s just for fun. This point is 0, 1. So remember, sine is y, so the sine of 90 is 1, and the cosine of 90 is 0. It's going to be interesting as we go around. Here we go. Let's continue. Oops. Sorry about that. Let's go back up. Okay. Even and odd functions, so remember, even are actually symmetrical over the y-axis, and odd means they flip around the origin. We don't use that a whole lot. A little bit here is helpful. If you know the cosine of a negative angle is equal to the cosine of the regular angle. So what this is saying is if I'm here and I know the cosine of this 45, which is the square root of 2 over 2, then I also know the cosine of a negative 45 is also the square root of 2 over 2. Remember, cosine is the x value, right? So the cosine of a positive negative angle is the same because x stays the same. All right, same as secant because these guys are reciprocals. Now sine, all right, so sine is the y value. Well, if you look here, the sign changes. It goes from, so here the sine of a 45 is a positive square root, well, I can't write, square root 2 over 2. But when you go down, now the sign is based off of y, so now it's a negative square root of 2 over 2. So this is saying the sine of a negative angle is the negative value of the sine of the positive angle, is what's helping us out here. Let's do a little bit of this. Cosine of a negative pi over 4 is the same as the cosine of pi over 4, square root of 2 over 2, because remember, cosine is based off of x. So x is the same sign, positive, negative. So if I go here to here, same sign, because I'm on the same side as the x-axis. Tangent is something divided by itself. Tangent is the negative angle becomes the negative, can you take in a negative divided by a positive, and you're going to get the negative 1. All right, now let's look at secant. Secant and sine. So let's do the sine one first. So I know sine of negative pi over 4 is the same as negative sine of pi over 4. I know pi over 4 is the square root of 2 over 2. And negative just means it went down, so it's negative because it flipped over the axis. Same with the secant. So this is just a negative square root of 2. I hope you did a good job. They expect you to memorize those, and you actually don't have to show any work. Reciprocal identities. This is not the same as there is a button on your calculator that looks like this, sine -1. It should say something, probably theta. That is not a reciprocal. This button finds angles. All right, the reciprocal identity on your calculator is actually the x to the -1. This finds the reciprocal. All right, so that's the button you're going to know. So if you find that, it should be on there. All of them should have a reciprocal button. All right, mine is like right above the 7. So it's going to be somewhere in that area, and we will be using this. So sine is 1 over cosecant, cosine is 1 over secant, tangent's 1 over cotangent, and so on. Okay, tangent is sine over cosine, so cotangent is cosine over sine. We use these quite a bit, especially in proofs later on, so they are good things to have memorized. So if the sine of t equals 2/5 and the cosine of t equals 21 over 5, I would like to find the remaining trig functions. So sine is opposite of cosecant. Tangent is when I take these two and divide them. So cotangent is the reciprocal of this. So I'm going to reciprocate this guy. So that's the square root of 21 over 2. Cosecant is the reciprocal of the sine. So that's 5 over 2. Secant is the reciprocal of the cosine. So this is 5 over the square root of 21. Of course, I have to rationalize my denominator. So that's 5 square roots of 21 over 21. Okay, pause and do yours. Okay, I hope you did a good job. Sine and cosine I just rewrote. Cosecant, we inverted sine. Cosine, we inverted, for secant, we inverted it and then rationalized our denominator. Tangent, we took the sine divided by the cosine. We had the same denominator, so they canceled. Then we rationalized our denominator and did the reciprocal for cotangent. All right, these Pythagorean identities here are used all the time in proofs. So these are ones you need to know. And we will be doing some proofs. They're not long ones, they're just to kind of get you into the habit of it. But there's only really one. It's a sine squared plus a cosine squared equals 1. If you need to pause, this would be a good time to do it and come back to it because this is a little bit different. If not, you're ready to go. To get to the rest of these, all you're doing is dividing. So like if I take the sine squared of t plus the cosine squared, of t equals 1. And I divided everybody by, let's say, the cosine. Cosine squared of t, right? I don't like the cosine this time. All right, sine divided by cosine is tangent squared. Cosine divided by cosine is 1. And 1 over cosine is your reciprocal, which is your secant. All they did was divide by cosine. The same is true here, they just divided by sine. So you really only have one, but the different identities help us get through things a little faster when we're finding trig functions. So here we have the sine of theta equals 3/4. It's between 90 and 180. This is important because it gives us the sine. So I know I'm in quadrant 2, and when I'm done, I have to find cosine, and I know cosine is x, and in quadrant 2 it is negative. So that means my answer has to be negative when I'm finished. That's what this does. It tells us what positive or negative value we have. And if they don't give this to you, you can't tell. You have to say it's either or. So we have sine squared plus cosine squared equals 1 because, the reason I picked that identity is they gave me sine, right? And they asked for cosine. So when I look at my identities, the one with sine and cosine is the first. It could be any of these and sometimes a combination of. So this is the one we're going to use. I plug in the sine. Now it's just solving. So you square 9 3/4 and you get 9/16. Subtract it, take the square root, and you're done. Now I look at this, I know my cosine has to be negative, so I use the negative value of the square root, and we are finished with that problem. All right, pause and do yours. All right, the first thing you should have looked at was what quadrant you're in, and you were in quadrant 1. Since you're in quadrant 1, everybody's positive, so the value must be positive when we're done. We were given sine, asked to find cosine, so we're going to use the first one again. Plugged it in, you got 1/4. You subtracted it over, you took the square root of both sides, say the square root of 3/2, using the positive value because that's what it told us to do. Hope you did a good job. All right, here we are on sine of theta equals 3/4, 90 and 180, so I know I'm in quadrant 2. I'm asked to find the cotangent. I know the cotangent is negative in quadrant 2 because that's x divided by y, right? Or y divided by x. Now, I asked to find the cotan, so the sine and cosine one is not going to work well here. So the cotan, the only one I have with cotan is 1 plus cotangent squared equals cosecant squared. So I want to use this identity. But if I'm given sine, it does not help me. But with the sine, I know its inverse is the cosecant. So I can invert this to get the cosecant, which is the value I need for this identity. So first step is I invert the sine. Now I plug it into my identity, square it, subtract, right? So now you're subtracting 9/9, which gives you 7/9. Now we take the square root of both sides, 7/9. This time it says the cotangent is negative, so the value I have to use of that square root is negative. Okay, pause and do yours. All right, I hope you did a good job. First thing we looked at is where we're given cosine and tangent. That means I have to use the 1 plus tangent squared equals secant squared. All right, which means I have to convert the cosine into secant. So I know the cosecant or the secant is 2. We just plug that into our formula. So 2 squared is 4. 4 minus 1 is 3. We took the square root. Up here, I was in the third quadrant. So since I'm in the third quadrant, the tangent is positive. Since tangent is positive, I use the positive value of the square root of 3. And that was it. I hope you did a good job. All right, periodic just means that this thing repeats. And I know these notes are long, but we're almost done. So a period if there exists a pause in our piece such that this repeats. All right, so like when I drew out the sine wave before, remember how it started here and it went down and up and down, right? Now it would continue to do this. So this repeats. It has the same pattern. This is a period. It's periodic. So sine and cosine repeat every 2 pi or every circle. All right, so their period is 2 pi. Tangent, on the other hand, is the division of these two, sine and cosine. So since tan of theta is actually the sine of theta divided by the cosine of theta, that makes it repeat every pi. So it is only repeating every 180, whereas sine and cosine repeat every 360 or every full circle. All right. I want to find the exact value of pi over 4. All right, so now I've got sine of 11 pi over 4. So 11 pi over 4, we have to figure out where that's at on my circle. So when I look at 11 pi over 4, so here we are. I'm drawing my unit circle here. That was terrible. All right, this is my circle, right? And we know my pi over 4s are here. All right, 11 pi over 4 is over a full circle because there's only 8 of them in here, correct? So the first thing I'm going to do is subtract the circle out. So now when I subtract a circle out, which is the 8 pi over 4, I've got 3 pi over 4. Okay, I know where 3 pi over 4 is, so I just count out 3. 1, 2, 3. Here is my 3 pi over 4. This is where I'm at on my unit circle. All right, sine, I know sine of 45 is the square root of 2 over 2. So I know this is square root of 2 over 2. I also know it's the y value, and I know y is positive in this side. So I know the sine of 11 pi over 4 is a positive square root of 2 over 2. Now, let's go down here. Okay, negative pi over 4, or 5 pi over 4. Now let's figure out where this thing is at. Again, I'm going to show you on a circle so you kind of understand. All right, negative 5 pi over 4, well, it's under a full circle. Negative means I'm going this direction. Let's change colors. So we're going to count here. We're going to go 1, 2, 3, 4, 5. So this is where I'm at. So this is negative 5 pi over 4. Well, negative 5 pi over 4, if I add pi to it, I'm at negative pi over 4. So if I got to add pi again, and the reason we're adding pi is because tangent is periodic over 180. So this time we add pi to get to where we want to be. So I add pi, that ends me up here. I add pi again, and it gives me a 3 pi over 4, which is what we were anticipating. Because if you go this direction, 1, 2, 3, we're at a positive 3 pi over 4. All right, I know tan is negative in this quadrant. All right, so I know my answer is going to be negative. And I also know the tan of a 45 is 1. So I know my answer is 1. I look at my quadrant, so now I know my final answer is negative 1. So the tan of negative 5 pi over 4 is negative 1. All right, the second option is to use that even and odd thing we learned before. So if I subtract pi, I got tan as a negative pi over 4. Well, this is in my realm, the pi over 4 is. I know that the tan of a negative pi over 4 is the same as the negative tan of pi over 4. Remember even and odd when we were talking about that? Equals negative 1. I do not care which method you use, whichever one seems best to you. All right, this is just saying what we just said. You can add as many circles as you want to sine and end up in the same spot. The same with cosine. This is adding circles. 2 pi is a circle. And with tan, you only add 180 or half a circle because that's when it repeats. That's where its period is. So sine is 2 pi, cosine is 2 pi, tan is pi. And the same with cosecant, secant, and cotan. Now, let's go down here. We want to check how the angle measurement is given. Now, change your calculator mode to match degree or radian. If you do not do this, you will get the wrong answers. So this is literally checking to see if you can use your calculator. So I want you to do the sine of pi over 3 and hit enter. If you do not get 0.8660, you are in the wrong mode. Make sure you are in radian mode. Now, when I ask you to find the sine of 60, and you type it in, you should get the same thing because 60 and pi over 3 are identical. Remember, we take pi over 3 times 180 over pi, our conversion. This cancels, and this is 60 degrees. You should get the same answer, but your calculator has to be in degree mode. It is literally making sure you remember how to get back and forth. Cosecant 1.5. We're going to assume something this small is radian mode. So change it to radians, but you do not have a cosecant button on your calculator. This is the same as 1 over sine of 1.5. To type this in your calculator, I know it is the sine, and I know I want the inverse. So you do sine of the 1.5, but we want the x to the negative 1 button. So you will type x to the negative 1, and it will invert this for you. Okay, you're not going to type this. This is a button on your calculator. If you do not have it or it is not working for you, you must type 1 and do the division bar, parentheses, sine of 1.5 and double the parentheses to get where you need to be. All right, try yours. All right, I hope you did a good job. My calculator, when you type in the tan of pi over 3, gives you square root of 3 over 3. If you want that in a decimal, you must cheat on mine. You have to do the square root of 3. Some of you may have the same thing. And then make sure you arrow out, divided by, and then when you do the 3 on the bottom, you have to add a decimal to it. When you add a decimal to it, it will give you a decimal answer. This one here was 1 over the cosine. She got at 2.5975. All right, good luck with your homework. I hope you do well. Don't forget to post discussion questions.